in another unscripted video, we're going to talk about our new handheld X-ray fluorescence analyzer. So this unit, as you can see, is our latest addition to the SciAps product family. And this is the lightest, the smallest, the fastest, most precise X-ray analyzer on the market, as far as I'm concerned, from what I've seen. And we've been out running around doing demos. It's got a great reception. So I wanted to show this quickly, just to show people kind of what it can do and show some nice alloy separations. A couple of nice features. First of all, same large display that's on the Z. It's an X-ray unit. It's a drift detector unit. If you look at the front of the unit, you see there's a stainless steel, I know it's stainless steel, shutter in front of the detector. So the way we have this unit operating is when you hit the trigger. I'm going to pull the trigger, so that's good, that's fine. When you pull the trigger, you'll see the shutter opens instantly, and when the test is over, you'll see the shutter closes right away. So the way we've designed that is that the only time that shutter is open is when you're testing. So the deal here is that most people, when they break detectors with these things, is because they stick their fingers or something else into this region when they're trying to change the proline window, and they just bump it, they put their finger in, they're trying to clean dirt off it, because that detector is very close to the front of the analyzer. So given our 20 plus years of X-ray experience, we really believe that almost all the detector punctures are because of that kind of thing. Now, with that shutter closed all the time, it's impossible, because obviously when the shutter is open, you have no reason to have your fingers anywhere near that, nor should you. And then there's a backup in there. When the shutter's open, now let's say you're sticking it into a barrel of turnings or something, but if by chance a turning pokes into the unit, there's a polymer mesh cover protecting the detector as well. So with this analyzer, unlike in the others, there's the shutter, high-speed shutter mechanism, and a backup window protector on the actual detector. Combining those things gives us really great STD protection. Alright, so let's just run through a bunch of different alloys to show how fast and precise this analyzer is. Here's the first one, a 316 stainless, 1 second, 316. And it's set up to always, it'll identify and give good chemistry on just about everything in 1 second. There's a few alloys that might differ by a little bit of, say, hafnium or tantalum, that it might take up to 3 seconds. But what you'll see when you're using this device is 95% or more of the alloys you're testing, 1 second is fine. This is this is a super alloy, a Utamet 500. There we go, 1 second Utamet 500. Just kind of keep moving along here. Let's see, here's another good super alloy. This is a B1900. Same story, 1 second, B1900. And what you can see on here, just like the Z, you get the elements, you get the name of the grade first of all, you get the elements, the chemistry, the plus or minus, and then you have the same grade comparison feature, so you can verify that every element is within spec. Yeah, this is my favorite, one of my favorites, this is a tie grade 7, which is only different from CP tie by 0.1 or so % palladium. So even this we get in a second. We pick up that palladium very, very quickly. And you can do that repeatedly. And just to show that there's no trickery going on here, we'll shoot a grade 1, which is just essentially pure titanium for our purposes. There you go, there's your grade 1. So that's how that works. So that's also a very, very, that used to take 20 seconds or so on some of the older X-rays. This is about a second. So it's quick. Here's another tie alloy. This is 6242. Again, 1 second, comes right up, good chemistry. This is a Monel. Shoot this thing. The X-ray has the same kind of camera view as the laser does. All the same software. It's all Android. So really, that's one of the things we promote, is that if you can use the laser, you can use the X-ray, and vice versa. The operating system is identical. The UI is virtually identical. It shares all the features. So the battery, which is back here, same battery that you have in the laser, and then same battery charger, so you don't have extra accessories. It does have a hot swap. It does feature hot swap battery, so you pull this out, you have about a minute to put a new battery in, or plug it into AC. The AC power goes through that port. USB, and then Wi-Fi, Bluetooth, GPS. So all the comms are there you need. So what did we not shoot? We shot, I think, a low alloy steel. That's good. All right, so let's do a couple more analytical things with the X-ray. First, we talked about precision, so I'm going to shoot a couple of nickel alloys. Let's shoot this guy first. Let's do 3 3-second shots. Here's the first one. So there's your 1 second ID. Okay, that's it for a 3-second test. Let's do another one. Here's the third one. Anyway, 3 tests. We can look at anything. Let's try chrome. 8.57, 8.58, 8.39. So the chrome is within 0.1 or so percent. Let's look at cobalt. 10.16, 10.18. Come on, you. 10.06. Very now. Let's go look at nickel. 66.25, 66.17, and 66.45. Those are great results. This is all fundamental parameters as well. I want to make sure that's clear. There's no this can do empirical analysis, but everything we've been testing is fundamental parameters. And one of our points is if you set the device up right with the right sort of geometry and good count rates and good resolution, you can really get great accuracy and great repeatability with a modern FP program. Let's look at something that was really, I thought, special. We did this at a recent demo. In fact, we were required to do it by the customer. It was I was really happy with how this worked out. This is a piece of wire. This is a cobalt stellite 25. Or L605, depending on where you are in the world. Cobalt wire is 0.005 inches in diameter, so it's roughly 200 microns. So what I'm going to do is tape it over this window. I'll show you we can analyze a single strand. So, thank you, ma'am. Let's just tape this over the window. All right, we'll show you. Can I do that? Can you see it? What do you think?
Yeah, we can see it.
Pretty good. All right, 200 micron. I'm going to put it up in the air, pull the trigger, so I'm shooting X-rays away. See, 3 seconds. There you go, HS25. So it can easily analyze that single strand of wire. So that was it. We can do this repeatedly. Let's do it again, just to make sure any of my friends out there in the competitor world think we're got lucky one time. We'll just keep doing it. Do this all day long. HS25 after 3 seconds on a 200 micron single strand wire. So that's the deal. I think that was really impressive. That impressed the heck out of some of our customers on that. So that makes a great demo. So any of you guys that do thin wires, this is the analyzer for you. So that's really the X-ray machine. Let's see. We've talked about high temp alloys. We've talked about wires. Of course, you can always do turnings with this thing. Let's get our badge of turnings, stick it in there, pull the trigger. There you go. These happen to be 3/16 turnings. So very good on turnings. Just shove it in there. All right, just do it again. Shoot it over here. Again, I'm not worried about doing this because of my protection on my detector. So we're all good. So there you go. There's your 3/16 on the turnings. Alright, it's a good way to give the scrap guy a heart attack is shove it into turnings. But again, we're pretty confident that we've got that detector well protected.